Hello, my name is Shumikal Bhattacharya and this is my task 6 of the Spark Foundation internship, which is prediction using decision tree algorithm. So we will have a quick look at the problem here, which is create the decision tree classifier and visualize it graphically. And the purpose is that if you feed any new data to this classifier, it will be able to predict the right class accordingly. The dataset is called Iris, which I have already downloaded. Let's go to R. So these are the three libraries that we need in order to perform this task, which is CA tools for splitting the data, rpart for creating the model of the decision tree, and rpart.plot to plotting out the decision tree. So I have already installed these packages and called the libraries. You can do that. Next we have to do is we have to load the data. As we can see, there are 150 observations of 6 variables. We can have a quick look at the head of the data so we can see what we are dealing with here. So as you can see, we have sepal length cm, sepal width cm, petal width cm, and what we are trying to do is we are trying to see what class uh, this belongs to. Like for example, here we are trying to predict the species. We can see if there are any missing values in this data. We can see that most of this is I've already checked the data. There are no missing data here. So then we can move on to splitting the data for training and testing. We are setting the seed here for at 128 so that if you do that you will get the exact same result as mine, as they will split randomly. There will be fixed random split. Now we're feeding the data where the split ratio is 70%. Then we're training the data. Then we're testing. We'll be testing the data and training the data as we go along. Now we'll try to build a model, uh, which I have used a variable tree here. We'll see. Actually, we have actually uh, built the model based on the training data. Actually, okay. So here we can see that we have used species, which the variable we're trying to predict on sepal and cm, all of the variables, and we have used the training data which we already assigned to the variable train, and the variables which are actually used in this tree construction is petal and cm and petal with cm, and there is root node error and the number of observations, which is 105, and all these details here. Then we can actually go and plot the data here, which will be on the base of the rpart plot library that we installed. We get a we get this decision tree. I mean, it's good. It looks good, but people might have some problem with this, as it's to my taste it's not very uh, soothing to my eyes. So what we can do is we can use the PRP function, and this is type 4 and extra 101. You can look it up in the help option of these extra arguments, and we can run this to get a more clear look of the decision tree visually, that it depends on the petal length and the petal width. Um, I guess this is it for the visualization part. You can look the details up at how a decision tree works in Wikipedia. And next, what we are going to do is actually make predictions based on the model and use our uh, test data. We can print this if you want to. If you want to, you can have this that there are three levels, and these are all the values that you will get. And you can also run a quick summary of the predicted uh, data. Finally, what we're going to do is we're going to compare the prediction that we already got right now versus the actual test data. First, what we have to do is we have to turn this test predicted data as a data frame, because if we don't do that, then we won't be able to get this table. So here we get the table that these rows are actual values and these columns are the predicted. That uh, we have one error here, which is out of the 45 observations of the test value. So which makes it a pretty good uh, classifier of tree, like good prediction based of the model we made in the decision tree classifier. Thank you.